On this page of notes, we're going to start really jumping into how can we use the All Students Take calculus to do some more advanced evaluating problems where instead of evaluating single angles, we're going to evaluate multiple angles in the same problem. We're also going to look at how to use the All Students Take calculus to help us figure out where an angle or a ratio should go in our coordinate plane very quickly. If you don't already have your unit circle filled out, go ahead and fill that out right now. Pause the video and fill that out. If you're still feeling a little bit weak on some of your ratios, remember there are master quizzes on Canvas that you can do to quiz yourself as many times as you want to get yourself down to a quick speed to quickly be able to recall these various ratios. Okay. Now, let's jump into, very quickly, some problems here. So I've got secant and tangent in this problem, and I notice that each of them are going to be squared. That's not going to really change what I'm doing. I'm going to treat these as two separate problems. When I find each ratio, I'm going to square them and then find their difference. Okay, that's really all we're doing here. This is just a way to put multiple problems in one single question. So secant, we remember, is the reciprocal of cosine. It doesn't hurt to jot that down if you want to remind yourself. It's the reciprocal of cosine. So we're going to grab our x-coordinate at pi over 3, but instead of using the 1/2, we're going to flip that over and we're going to write a 2. We know we have to square that, so we can just write 2 squared. If you want to do that in your head right now, you can. I also know that I'm going to do tangent of pi over 4. I know that from experience that tangent of pi over 4 is going to be 1. I can come up here to my unit circle, pi over 4. I can see my 1 has been circled, and that's my tangent. So I'm going to do 1 squared. So I have 4 minus 1, or my final answer is 3. So you can see we didn't do anything different in these problems than we did last class. We're just adding a couple extra steps and combining questions. Sine of pi over 6, grab my y-coordinate at pi over 6. It's going to be my 1/2. This time I'm going to multiply my answer by whatever I get for my tangent of negative 5 pi over 3. Remember, negative 5 pi over 3 is going to rotate all the way around and is actually going to land me back into my first quadrant. So tangent of my negative 5 pi over 3 is going to be my square root of 3. I like to write it over 1 since my other question was written as a 1, so my final answer, radical 3 over 2. Secant of negative 7 pi over 4, that means I'm going to need the reciprocal of cosine wherever negative 7 pi over 4 lands. That's going to bring me all the way around, land me in the first quadrant. So I need the reciprocal of radical 2 over 2. This is one where at this point you want to start getting these in your head, that the reciprocal of radical 2 over 2 is just going to be radical 2. I'm going to subtract that, and I'm going to multiply my next answer by 6. So I've got cosecant, that's going to be the reciprocal of sine, of pi over 3. Come up here to pi over 3. I'm going to grab my y-coordinate. I can do this in my head because what I really have going on is 2 over the square root of 3 that in my head I can rationalize. So I know I'm going to get 2 radical 3 over 3. Cleaning up these fractions, 3 goes into itself once, 3 goes into 6 2 times. So my final answer is the square root of 2 minus 4 square root of 3. Again, not much different than what we've been doing. Now, moving away from our unit circle, our problems here at the bottom of the page actually are not going to use our unit circle. Instead, I can see that I'm going to be given a ratio that's not one of the ratios that came from my unit circle. The other thing when I look at this problem, just eyes being drawn to this ratio, is that I can see this ratio must have been rationalized because the radicand and the denominator are the same. So I like to rewrite these problems immediately as 2 over the square root of 7. It's going to make my work a little bit easier as I continue on. So I'm given two pieces of information, that I have an angle that's acute and I have a positive ratio. So what I can do is I can figure out, since it's an acute angle, it needs to go into my first quadrant, and I can draw this triangle. The next thing is that sine from SOHCAHTOA is opposite over hypotenuse. So I can put a 2 here and a square root of 7 on the hypotenuse. And then very quickly I can do my Pythagorean theorem. Square root of 7 squared is going to be 7. 2 squared is 4, plus an x squared. Do this in your head. You're going to very quickly get square root of 3 for that last side. Tangent is going to be my opposite over adjacent. So I just grab it from my triangle. So 2 over the square root of 3. If I want, I can write it down, but I am going to rationalize in my head. 2 radical 3 over 3. On question B, I'm given some slightly different information. So on this one, I'm given that the cotangent of my ratio is supposed to be negative. So now is when I want to think about that all students take calculus. Okay? If my cotangent is supposed to be negative, then that means that tangent was negative. So I need to think, what quadrants is tangent negative? And tangent is negative in these two quadrants right here. Next, I can see that my cosecant, which is the reciprocal of sine, is negative. So I need to choose which of these two quadrants would give me a negative sine ratio, and that's going to be the fourth quadrant. So I'm going to draw a quick little triangle in there. I'm going to remember either from SOHCAHTOA that sine is going to be the hypotenuse over the opposite, or I can think from my trigonometry that sine is going to be, or cosecant is going to be r over y. Either way, I'm going to put these values onto my triangle. So my hypotenuse is going to be my 5. I'm going to keep that positive. My opposite is going to become my negative 3. What you may recognize is that this is a 3, 4, 5 triangle. We can also very quickly do a Pythagorean theorem and get that exact same answer. Some of our simple Pythagorean triples are ones you would want to know in your head. We're asked to find cosine. It's adjacent over my hypotenuse, or I can also think x over r. Either one, it doesn't matter to me. So I'm going to use 4 over 5, and now I'm done. Here's another situation where we're going to take a look at how we can combine two pieces of information. This time I'm told that my angle has to be more than pi. So that means that I'm going to rotate past where I know pi is supposed to be. So that means that my angle has to be in the bottom two quadrants. Next, I know that my cosine is negative. So thinking cosine is positive, I'm sorry. All students take calculus. Which of these quadrants will my cosine be positive? This, again, is going to be my fourth quadrant. Cosine is my adjacent over my hypotenuse, or as I said earlier, we can write that x over r, whichever one you want. So I'm going to go ahead and put my 12 and my 13, and you may recognize this as a Pythagorean triple, which in fact it is. This will become negative 5, or you can do your Pythagorean theorem to figure out that value. A very quick 169 equals 144 plus I'm going to write a y squared. Remember, our Pythagorean theorem is going to give us a positive number, but we have to think about where it is in the coordinate plane that would give me a negative number when I label it. Lastly, cotangent is going to be adjacent over opposite. Just grab my two values there, negative 12 over 5. Last problem on this page. You can write our all students take calculus. Never hurts to put those in the corner. Sign needs to be negative. So I'm going to eliminate these two quadrants as possible places because these would give me positive values for sine, so I'm going to eliminate those. Lastly, tangent needs to be positive. Of my remaining acceptable quadrants, tangent needs to go in this quadrant. My triangle does. So tangent is supposed to be 1, so I can think of that as a 1 over 1, or in my case, I need to remember these would both be negatives. Now, this one you should recognize as one of your special right triangles, so we shouldn't have to do Pythagorean theorem on this one. We can also recognize that this number did in fact come from our unit circle, so if we forgot, this is really a backup method. Lastly, I'm looking for secant, hypotenuse over adjacent. So I'm just simply going to do my hypotenuse over my adjacent, or a negative radical 2. And that's it for those.